Today, we will watch informative clips all about tubing performance curve. We will all learn about effect of liquid-gas ratio, effect of liquid density, effect of liquid viscosity, effect of liquid surface tension, effect of kinetic energy, effect of subsurface choke size, effect of surface choke size, effect of flow line size, effect of separator pressure, effect of combined effects. Make yourself ready because as engineers, it can help us with our future. Tara at samahan niyo ako sa aking paglalakbay. Ako nga pa pala si Kuya Justin at kami ang Group 3. Three.
I'm Christian Jules Marcelas and I'm here to discuss about the effects of gas and liquid ratio. The primary distinction between single-phase and two-phase reservoirs is that the producing GLR in the latter varies with time as reservoir pressure decreases. The density of the produced fluid decreases as GLR increases. This results in a temporary reduction in the required flowing bottom hole pressure. The figure 2.1 depicts the application of GLR curves. The key is to enter the curve at a point defined by the rate, GLR, and flowing tubing pressure or BHP, and then move along the appropriate GLR line by an increment equal to the depth. Do not simply read the BHP conditions at a given depth. This corresponds to a THP value of 0. Thank you.
I am Mary Quincy Abad and I'm here to discuss about the effect of liquid density and effect of liquid viscosity to tubing performance curve. But first, let me discuss about the effect of liquid density. The density of liquids is affected by the density in a way that as the density ratio decreases, the front end positions move faster. As the density ratio decreases, the distance between the liquid's front head positions and the particle grows wider. A liquid's density determines whether it will float or sink in another liquid, and floats a liquid that is less dense than the liquid in which it is placed. A liquid sinks when it is denser than the liquid in which it is placed. As the density of liquid decreases, so does the pressure required to flow through the bottom hole, as you can see in figure 3.1. It depicts a comparison of the effect of APA gravity crude on fresh and salt water respectively. From figure 3.2, it depicts the relationship between required flowing bottom hole pressure and the water-oil ratio or density change as a result of changing water percentage in a petroleum reservoir. And the second one is the effect of liquid viscosity. The effect of density on liquids is that the viscosity of liquids decreases rapidly as temperature rises, whereas the viscosity of gases rises as temperature rises. As a result, liquids flow more easily when heated, whereas gases flow more slowly. The amount of friction determined by viscosity determines the amount of energy absorbed by the flow. From figure 4.1, it demonstrates that as liquid viscosity increases, higher flowing bottom hole pressures are required. Thank you.
Effect of liquid surface tension. Surface tension is defined as tensile force acting on the molecules of the liquid at the interface of liquid and vapor due to unbalanced force acting on the surface molecules. It depends on the nature of the liquid, impurities, and its temperature because of different liquids having different forces of attraction and repulsion between their molecules, as well as impurities decreasing over surface tension and temperature increasing as surface tension decreases, until it becomes zero at critical points because with increase in temperature, intermolecular forces also decreases. Effect of kinetic energy. The influence of kinetic energy on flowing pressure can become significant since it is critical for small diameter tubes with high gas or liquid ratios and low pressure levels. The most helpful display of tubing performance for well design is to plot flowing bottom hole pressure versus rate for various tubing sizes and gas liquid ratios. There is a minimum flow rate necessary for continuous extraction of liquids from the well regardless of tubing sizes, which is the rollover point in the tube performance curve. Once the velocity hits about 5 feet per second or 1.6 meter per second, the well will be unstable, which is known as liquid holdup, and it is caused by gas phase slippage through the liquid. The higher the liquid holdup rate, the larger the tube diameter.
Hi guys, my name is Val Anthony Culina and my topic is effect of subsurface choke size. The subsurface choke is the second significant source of possible pressure reduction within the generating equipment circuit. Within the tubing string, subsurface chokes are inserted at varying depths. The choke's installation depth is mostly determined by the service function it performs. Based on the picture, it shows that the pressure draft effect for 5 different choke diameters at varying flow rates. In example A, the chokes are installed at 10,000 feet, while in example B, they are installed at 2,500 feet. Even though the flowing bottom hole pressure is set at 5,000 psi, in both scenarios, the pressure drop is continuously greater for the shallower installation.
Surface choke. In order to control the flow rate of the well at the surface, a surface choke can be installed to control the flow rate of the well. Although a choke device is used for a number of purposes at the surface or downhole, its principal use is to control the flow rate and the pressure of the produced hydrocarbon at the wellhead. The effects of surface choke size, as you can see in the figure 4.15, pressure drop is plotted as a component of upstream tension before the choke for the three different surface choke sizes. Note that the tension drop diminishes as upstream strain increments for a consistent stream rate. As you can see in the figure 4.16, upstream strain is consistent at 5,000 psi and stream rate is variable. This plot represents the impact of choke size on both strain drop and the greatest potential stream rate.
The effects of flow line size. The surface flow line is the next significant area of pressure loss inside the producing equipment system. A large flow line will reduce the pressure drop in the flow line, shifting the outflow down in the intersection to the right. The effect of a change in any component in the system can be isolated by this manner. The figure shows the effect of flow line size and length upon required flowing pressure gradient for a 1000 STB per day water well. The effects of separator pressure. Separator pressure is maintained at a constant and stable level. Small adjustments in separator back pressure can have a noticeable influence on flow rate under certain conditions. The increase in partial pressure reduces the component's equilibrium constant, and the molecules of that component tend toward the liquid phase. As the pressure of the separator increases, the liquid flow rate out of the separator also increases. Pipe fittings such as valves affect the performance of separation vessels. A pressure drop across a valve creates a shearing effect on droplets, making them smaller and more difficult to separate. By optimizing the configuration and location of the vessel's inlet piping, droplet coalescence can be promoted, which is beneficial to the performance of the separator. And the figure was developed by flushing several crude oils of different gravities at different pressure ranges. The curves are approximate. The actual shape would depend on the initial separation pressure, the number and the pressure of intermediate flushes, and the temperature.
Figure presents a step-by-step summation of pressure drop effects for two different equipment systems. Reservoir parameters are identical in both cases. Flowing bottom hole pressure is constant at 5,000 psi. In both situations, curve 1 through 5 indicates the same values. Curve 1 depicts the impact of tubing size and length on the pressure drop at different flow rates. Curve 2 takes into account the impact of both tubing size and subsurface choke size. Curve 3 depicts the combined impact of tubing diameter, subsurface choke diameter, and surface choke diameter. Curve now includes the influence of flowing size. 4. Curve 5 and adds the influence of separator pressure to all the previous outlined effects. This figure depicts the effect of minor modification to the equipment system on a flow rate and necessary flow rate bottom hole pressure. All the circumstances are the same in the figure, with two exceptions. The subsurface and surface choke diameter have been reduced to 1/4 inch. It is clear that size this small, changes had a big impact on the system productivity.
Join us again, our future engineers, and learn more about to be one of the most successful petroleum engineers in the world. Thank you and God bless.